Hi, I'm Olga Mali and this is Math Talk. Today my guest is Christopher Heinzel from our college. Hi, Chris.
Hi, everybody. It's good to be here today.
Thank you, Chris, for joining me. And Chris will help me to work with calculus 2 problem, which is volume of a solid of revolution. And we will show you today how to work with disk and washer methods, and also how to work with shell method. First of all, let's just look at the formulas. So what formulas do we know? For disk and washer method, we have two formulas. Volume is pi integral from A to B, and then we have outer radius squared minus inner radius squared dx. This works for case when we have horizontal axis of revolution and our representative rectangle looks like this with the side dx. Another formula looks like this. Volume is pi integral from C to D, and again we have outer radius squared, but radius is now function of y, and we have inner radius squared, and integration is with respect to y. Picture corresponding to this case will look like this. So now we have rotation about y-axis, and this will be our representative rectangle with side dy. So this is for disk and washer method. Now, what about shell method? So I just want to write formulas for shell method as well. So volume is 2 pi integral from C to D, radius of our shell, height of our shell, dy. So this is for the case when we rotate about horizontal axis, and this is our representative rectangle with short side dy. And another formula, if we have our functions of radius and height as functions of x, we will have an integration with functions of x, r of x, h of x, dx, and picture corresponding to this case will look like this. We rotate in our region around y-axis, and representative rectangle looks like this with the short side dx. So r is radius of the shell and h is height of the shell. Before we start working with particular example, I just want to draw your attention on location of representative rectangles. When we work with shell method, look at these two letters. Don't they look like parallel lines? So representative rectangle is parallel to axis of revolution. And when we work with disk or washer method, representative rectangle will be perpendicular to axis of revolution. So now let's talk about our example. And so Chris, you will be working on the right side showing shell method, and I will be covering disk and washer method on the left side of our board. So let's say we have equation y is x cubed. This is function, and we're talking about region bounded by this function, line y equals to 0 and x equals to 2. And rotation will be about x-axis. So how does it look, the picture? So I will draw here a picture for my case. I'm working with disk method, disk and washer method. So the part of x cubed will look like this. And where is our line x equal 2? So this is 2. So this would be this part. This point is 8 accordingly. And this is the region which we rotate about x-axis. Okay, so Chris, you can repeat the same You can choose red color. Just repeat the same picture on your side. Okay, very good. And rotation is about x-axis. So we have the same thing here.
Right.
Okay, and this is our shell method. Step number 1 in all cases. Step 1, we need to decide on our representative rectangle. Will it be perpendicular or parallel to axis of revolution? Step number 2, we are going to decide what are we working with, integrating with respect to x or y. And step number 3, we need to decide on limits of integration. If we work with x, so limits will be on x axis. If we work with y, yes, Chris, limits will be on y axis. Okay, so I will start. In my case, here, with washer disk method, we remember that representative rectangle should be perpendicular to axis of revolution. So this is my green representative rectangle. It's perpendicular to axis of revolution. And since the short side is here dx, we understand that we are going to integrate with respect to x, variable x. So what is the formula? Formula is pi integral. I have outer radius squared minus inner radius squared, and I already decided I integrate with x, variable x, so this is dx, and limits of integration will be along x-axis from 0 to 2. From 0 to 2. Now I need to decide about radius. What is outer radius? Outer radius is y. So outer radius is y. This is just y, which is x cubed. And Chris, what is inner radius? Inner radius, do we have it at all? We don't.
No, we don't.
Yeah, we don't have any holes, right? Inner radius means we have a hole somewhere. We don't, so it's just 0. So the whole integral, now we look pi integral from 0 to 2. X cubed squared will give me x.
The 6th power.
X to the 6th power, dx. So this is 6th power, which means I will get pi, and we take integral of x to the 6th, which is x to the 7 over 7, and with limits of integration from 0 to 2, we will get just 128 pi over 7. So this is how we do it with disk or washer method. Okay, so let's have a look how shell method will work in this case. So Chris, let's start with step number 1, representative rectangle. Representative rectangle is parallel to axis of revolution. So this is our representative rectangle. Okay, so what is the next step? Short side is dy. So we're integrating with respect to y.
Right.
Okay, so what is the formula? Formula is 2 pi integral radius times height, and we integrate with dy. Okay, so write dy there. And limits of integration from 0 to 8. Okay, so radius and height here should be both functions of y. Okay, so let's have it. So radius is equal to y, right? And what is height? What will be height of our shell?
It'll be 2 minus x.
2 minus x. Yep, so this is x, so 2 minus x. And what is x? We don't have x.
So we need to make our original function, which was a function of x, a function of y. And by doing that, we get 2 minus y to the 1/3 power.
Okay, very good. So now we need to put that all into our integral. So we will continue. So it will be 2 pi integral from 0 to 8. So r is just y and h is 2 minus y over 1/3 power dy. So this is simple power integral, right? So we just distribute this y and we solve it just using power rule. And the answer will be exactly the same. The answer will be 128 pi over 7. So whatever method you use, you will get the same answer. Okay, so in this case, we just had very easy problem, revolution about horizontal x-axis. Now, let's have a look at slightly different problem. I will have the same function y equals x cubed, and the region bounded with that function and the same two lines, y equals 0 and x equals 2. So we have exactly the same picture. So this is our function, and this is 2 and this is 8, and this is the region which we rotate about line y equals to 8. So where is this line? I will do it black. So this is the line, and we rotate about this line. And again, let's use both methods. So when we rotate our region about this line, we will get something like this. So this part will go over there, and this will go over there. So we will get hole here in between. And first we are going to use washer method. So I remember the formula. Volume is pi integral from a to b, outer radius squared minus inner radius squared, and then I need to decide will it be dx or dy. So what are the steps, Chris? So step number 1, representative rectangle. How representative rectangle will be located in this case?
It'll be perpendicular.
Perpendicular to axis of revolution. Remember, shell parallel, so the other case will be perpendicular. So this will be my representative rectangle here, somewhere here, green color rectangle. Okay, so what is the short side? Dx, which means we are going to integrate with respect to x. So in my integral, I have dx, and limits of integration will be on x-axis, right? So which means from 0 to 2. Okay, so I will just write it here now. Volume is equal pi integral from 0 to 2. What is outer radius, Chris, from the picture? What do you see? Where is it?
8.
It will be 8, because if this is black as our axis of revolution, outer radius will be here. So this is just 8 units. So this is 8. Okay. What is inner radius?
8 minus y.
Exactly. So where is it? This will be the distance, which is our inner radius. And this distance is total, which is r, minus this distance, which is y. So it will be 8 minus y. Now we remember that everything should be a function of x, so it's just 8 minus x cubed. So this is what we are going to put in our integral. So first we have outer radius squared, which is 8 squared. And then we subtract inner radius squared, which is 8 minus x cubed squared. And we know that everything is integrated with respect to x. So this will be our function, our integral. And after this, we just need to sort out everything in parentheses. We will get pi integral from 0 to 2 of 16x cubed minus x to the 6 dx, and the final answer will be 320 pi over 7. You just need to use again power rule for this problem, for this integral. So again, we use the same steps. Step number 1 was our decision about representative rectangle. Step number 2, dx or dy, and we know it's dx. And step number 3, limits. Okay, so that was disk method, or rather washer method, because we have two expressions for radius. Washer method. Okay, now we will show you the same example with the shell method. So Chris, you will help me. I will just draw a picture here. So we have the same picture. This is our region. This is 2, this is 0, this is 8. So this is our region. And again, we rotate it about line y equals to 8. Okay, so what do we do with the shell method?
Well, first off, we draw our respective rectangles so that it's parallel to our axis of rotation or revolution.
Draw it. Okay, so this is our red rectangle. I'll just make it a little bit more red. Okay, so short side is dy. So what does it mean? We're integrating with respect to x or with respect to y?
With respect to y.
Okay, so let's write our formula.
And because we're integrating with respect to y, we need to use the limits from the y-axis.
Yeah, so this is our y-axis, so we're using from 0 to 8. Then radius and height of shell should be functions of y in this case. Okay, very good. So we decided on everything except radius and height. So what is radius of this shell?
It's 8 minus y.
Okay, so how do we see it? So radius of this shell will be from the distance from axis of revolution to our representative rectangle. So we draw it as a large representative rectangle, kind of thick one, but in reality it's tiny thing. So we have this distance, and this distance will be total, which is 8 minus the distance to get to this representative rectangle, which is y. So that's why we have 8 minus y. Okay, what is height?
2 minus x.
Okay, can you show us how do you know that it's 2 minus x on the picture? Where is x? This is x. So the height of this shell or representative rectangle will be just this distance, which is again total, which is 2 minus this x. That's how we get this distance. So it's 2 minus x. But Chris, we need to integrate with respect to y, so we don't want x there. What do we do?
We take our function, which was a function of x, and make it a function of y, which again,
so it was x cubed. So now what?
Which makes it 2 minus y to the 1/3 power.
Okay, great. So now plugging everything into our integral. Okay, very good. So we will just skip all algebra here, how to use FOIL, and then we just use power rule again, right? It's all power. So what's the answer?
It should be the exact same.
So you should get exactly the same, 320 pi over 7 at the end. Okay, very good. So, so far we have been working with rotation about horizontal lines. Now, let's look at what happens if we rotate about a vertical line. And again, we will work with the disk washer method and shell method separately. We're using the same function, y is x cubed, and the region is bounded by this function, and y equals 0 line and x equals 2. So exactly the same what we did before. So this is my function, this is 2, this is 8 because 2 cubed is 8, and this is the region we are working with. And let's rotate it about line, about vertical line, x equals to 4. So where is this line? So this would be 4, and this will be the line, and we rotate about this line. So we can see that we will get a nice hole in our shape, right? So all this region will give me a hole when we revolve it around this line x equals to 4. Again, the same steps. For disk or washer method, what will be representative rectangle? How do we graph it here? Perpendicular to the axis of revolution?
Perpendicular.
Perpendicular. Again, we remember shell parallel, or if we want, we can always write the word shell and see these two parallel lines. And since we are working with disk method, now we know that will be perpendicular. A rectangle will be perpendicular to axis of revolution. So I just draw it here. And again, I'm making it thick, but we know that the representative rectangle is tiny, right? X or dy, they are very tiny. Okay, so what do we have here? What is our small side? Dx or dy?
Dy.
So this is dy, which means we are going to integrate with respect to y. So the formula for washer method, let's just write here that we are using washer method. So formula will look like this: pi integral, then we have outer radius squared minus inner radius squared dy, and we know that both functions, radius, which is outer radius, and inner radius, they should be functions of y in this case. Okay, what about limits of integration? Chris, third question. What will be limits of integration?
The lower limit will be 0, and the upper limit will be 8.
And why is that?
Because we're integrating with respect to y.
Yeah, great. So we're going along y-axis from 0 to 8. Okay, now I need to decide about expressions for outer radius and inner radius. So what is outer radius?
4 minus x.
So how do we see it? Where is our outer radius? Outer radius will be this part, right? The remote part of our rectangle and distance from it to axis of revolution. So we have this distance. Kind of we're sitting here and looking at our rectangle, and we see this side. So what is this distance? We can take the whole distance, which is 4, and we need to subtract this distance, which is x. So indeed, we just get 4 minus x. Now, we need to stop for a second. We're integrating with y, right? Y variable. So I cannot have here x. So what do I need to do?
We need to take our function of x and make it a function of y.
Yeah, so we remember that y is x cubed. So we just write 4 minus y power 1 over 3. Okay, great. So we sorted out outer radius. Now what about inner radius? What is our inner radius?
It'll be just 2.
It will be just 2. So where is inner radius? Inner radius is just from here to here, which is, we know, since this is 2 and this is 4, is just 2 units between them. Or I can say that it will be 4 minus 2. So total distance is 4, and we subtract this distance, which is 2. So we have 4 minus 2, which is equal to, so now I can put everything in my integral here. So pi integral from 0 to 8, outer radius is function of y, will be looking like this: 4 minus y 1/3 power squared minus inner radius squared, which is just 2 squared, and we have dy. So now, Chris, how to solve this integral? What we are going to do?
We're going to FOIL 4 minus y to the 1/3.
This, yeah, you can FOIL, or we can use formula, which is perfect square trinomial formula. A minus b squared is first term squared minus twice of their product and plus b squared, right? So we can, or you can use FOIL. So after we simplify everything, then it's just very easy. It will be again integral to be solved with power rule, and we will get our answer. It will be 96 pi over 5. So we used Washer method for this problem. Now let's do the same with shell method. So I will use another page, and now we will do shell method. And again, the picture will be exactly the same, so we're always working with the same function. So this is our function, y equals x cubed, and this is 2, and this is 8. We have axis, and again we will rotate about vertical line, x equals to 4. So we're rotating about x equal to 4. So this is our axis of revolution, and we show it here. This is 4. And this is our region, and we start our work. So step number 1, what do we do?
Draw a respective rectangle.
Yeah, representative rectangle. Now, parallel to axis of revolution or perpendicular to axis of revolution?
Parallel to axis of revolution.
Use this. Okay, so let's draw it. Okay, very good. So this is our rectangle, and we working with dx. Yeah, the only thing what I would do, let's draw this dx, the short side, on x-axis, okay?
Oh yeah, so it
Yeah.
doesn't get confusing.
Otherwise it's confusing.
Right.
So this is our representative rectangle. I will just make it a little bit greener. And the short side lies on x-axis, so it's dx. Okay, so we need to decide now. Are we integrating with respect to x or with respect to y?
We're integrating with respect to x.
Yep, so this is our next answer. So we're working with dx, integrating with respect to x. And what will be the limits?
0 for the lower limit and 2 for the upper limit.
And why is that?
Because we're integrating with respect to x.
Yeah, so we're moving our shells this direction, collecting volumes of those shells, moving them along x-axis. Okay, great. So answered all questions. So now time to write our formula. From 0 to 2, integrating.
Sorry about how that R came out, everybody.
Oh, that's okay. We can just correct it a little bit. No problem. Okay, I made it worse. Okay, fine. So this is radius of our shell and height of our shell. Both are functions of x. Okay, great. So now let's decide what is the radius of our shell.
4 minus x.
Okay, so how do we see it? This is 4 total, and this is x. Yep, and this is because we are looking for this distance, right? So it will be difference. It will be 4 minus x. This is radius of the shell. So we are looking from here to our shell, and this is distance of 4 minus x. Okay, great. Now, what about height? Height of the shell, or height of this cylinder?
It'll be y, which is really just our original function, x to x cubed.
Yeah, exactly. So the height will be just y, from 0 to y, which is just y, and this is very convenient because it's x cubed. Okay, so let's just write the integral. What do we have? 2 pi from 0 to 2. Okay, great. So how are we going to solve this integral?
We're going to distribute x cubed into 4 minus x.
Okay, we're not going to solve it to the end because this is again very easy, it's just power rule, but we would recommend you to do it on your own, guys, because you will get the same answer. You should get the same answer, 96 pi over 5, the same which we got in the previous example using washer method. Okay, so Chris, I think we covered everything, right? Different axes of revolution, horizontal, vertical, moved axis like here when we have it moved to x equal 4 line and horizontal lines. So I think we are good. So thank you so much. I hope that will help our students a lot. That was Math Talk and Olga Malley. Thanks for watching.
Bye.